Hi, welcome to another edition of Math with Mr. Douglas. Today we are going to be looking at graphing linear equations, but this time focusing on slope. Taking a look at how you can interpret slope. Also in the challenge section we are going to be looking at word problems, and we might also look at a really cool program called Desmos. And if you do really good, you might get a cookie from the Death Star cookie jar. What do we have? Oh, it's homemade cookies. All right, let's get to the math. Oh, that's pretty good. So we're talking about slope, and I love to go snowboarding. So here's my mountain, and there's lots of different mountains that I've gone snowboarding on. There's definitely some different ones. If you're familiar with beautiful British Columbia, the best mountain, of course, is Whistler. But there's also some other ones that are kind of closer to downtown Vancouver. There's Grouse Mountain, and there's another one which I really liked, which was called Cypress. So both really great mountains. And we're talking about slope, so that's kind of the topic right now is slope. And don't forget, slope is designated by the letter M. So we're talking about slope. We're really talking about how steep things are. So if I was going to look at, say, the slope of this Whistler Mountain, so if here is a little guy, and for some reason he's on a snowboard, and he's trying to go up, which is kind of weird, but just work with this right now. And say there is this guy, and he was on a snowboard, and he was also going up. And I say, which slope is steeper? And I think you could obviously see that the Whistler Mountain is a little bit steeper than the Cypress one. So when we're talking about slope, if I saw something that said, this slope is 8, and this slope is, 2, which one has the bigger slope? What I'm talking about is which one is steeper. And then let's say, at the top, everybody's kind of having fun, and then there's this girl who's maybe she's skiing and that kind of stuff. So she has little skis on, and she has her ski poles and stuff, and she's going down. And again, then she jumps over to the Cypress Mountain, and she's still skiing, which I'm not a huge fan of skiing, but let's say she's skiing. And she's going down, so she's still the same kind of steepness of slope. She's going down now, so now it's a negative slope. So when we're talking about positive slopes and negative slopes, when you're going up, we're talking about positive slopes. And when you're going down, we're talking about negative slopes. So things to kind of keep in mind for that. And then if two people were going up the exact same mountain, so let's say there's another person here. So say the little girl's like, hey, I want to go up the mountain again. So then they're both going at the same time. So there's the little girl, and apparently she's changed color now, but whatever. And they're both going up. Well, then we would say their slopes are parallel. They're going up the same way. Their slope is the same, so it's parallel, like that. So that's a parallel slope. So whenever the slopes are the same, we say it's parallel. And just for fun, we're going to talk about this later. If slopes are, so maybe we could just go like this. This is actually probably a good thing to write down. So if slopes are parallel, they have the same slope. So the same slope. And if the opposite of parallel, of course, is perpendicular. And we're going to do a whole lesson on this. But since I've talked about it, these are negative reciprocals. Whoa, those are big words. That just happened. So if we had like slope 1, so m equals, let's say, 5. Slope 2, if we're going to be the same, m is 5. Okay, but if you're negative reciprocal, it doesn't mean it's a negative number. It just means it's like the opposite. So let's say your first slope was negative 2/3. Okay, so in kids' terms, so slope 1. Slope 2, if you wanted to be perpendicular to that slope, you would have to flip it and change the sign. So that's the kid version. Flip it and change the sign. So I'm flipping it, 3 over 2, and I'm changing that negative to a positive. So these slopes would be considered perpendicular. So if these m's are like this, that's perpendicular, and these would be considered parallel. Okay, I didn't really want to talk about that, but since it kind of came up, I did. So what we should be talking about is actually using the formula, counting, and using tables to figure out slopes of things. That's really what we want to be doing today. So let's get right into it. If you want to figure out what the slope is, so you want to figure what m is. So remember, we're always working in this. Y equals mx plus b. So we're working on the m right now. So slope is m, and so slope is m, which is rise over run, which is the change in y over the change in x. That got really fancy there, didn't it? Don't worry, it's not that bad. So I'm just going to do a quick little 4x4 grid, right? 2, 3, 4. So 1, 2, 3, 4, 1, 2, 3, 4. And here's some points. And the easiest way to figure out slope, the very, very, very easiest, is going to be just counting. So here's my line. That was my line sound effect. And you're just going to go and count. So we are going to count between these. So the rise over the run. So it rises 1, 1, 2, 3, 4, 5. So it runs 5 and it rows 1. Slope is rise over run. So how much did it rise? 1. How much did it run? 5. Your slope is 1/5. It's a very gentle slope. It's a very easy ski hill if you're going up it, like that. But let's say you had one was like this. Here we go. And we'll make it like that. And let's say it's going down like this. We're going to go and count this way. So it goes down 1, 2, 3. And it goes across 2. When it goes down 3, we say it goes down, so negative. And again, it went across, so that's 2. So what's the rise? It rose -3, which means it goes down. And it ran 2. So that's the slope for the blue line. So a negative slope. Okay, so that's just counting. Easy peasy, no problem. But what if you are not counting? What if they just give you points? So what if they say, tell me what m is? If a line passes through, say 5, 2, and 3, 4. So what's the slope if the line passes through there? Now, I know what maybe some of you are thinking. Why don't you just go and graph it, Mr. Douglas? So like 5, 2 is probably over here, and 3, 4 is going to be probably up here. So why don't you just go and graph it and then just count? Couldn't you just go do that? Well, sure you could. But let's just say we're not going to do that. There's an awesome formula. Yes, it's formula time. So the formula for figuring out slope, and you might have already heard this, it's y2 minus y1 all over x2 minus x1. Well, what does all that mean? Do you mean y squared? No, I mean y2. That's why it's a subscript right now. So what you end up doing, the steps to go and do this is pretty easy. So, step 1. So step 1 is label the points. So label your points. And step 2 is plug in and solve. Plug in and solve. That's it. So I'm going to label my points. It doesn't matter which one you make 1 and which one you make 2. But this is your x. This is the very first x. This is x1. This is your very first y. So I make it y1. And then we have this as being my second x. And this is my second y. Great. I'm going to take these numbers and just plug it into these things right here. So let's just imagine again, we didn't go and graph it, right? And we just did this the equation way, which trust me, you're going to want to do anyways. Now I'm going to do this a little bit slow. I want to make, so I'm actually going to go and put brackets and there is a method to my madness for this, and this all equals m. And I'm going to put the m over 1. See, it forms a proportion. Pretty cool. Let's go plug in the numbers. So this is y2. So what number is y2? 4. What number is y1? 2. And what number is x2? It's 3. And then we have 5. Wow. So the math is crazy in this one, right? 4 minus 2. 2. 3 minus 5. Negative 2. I'm going to simplify that, because we always simplify. So it's negative 1. Our slope is negative 1. Boom. Not too bad. Shall we try another one? Why, yes. Yes, we shall. Because there is a common kid mistake. Actually, there's a few of them. So let's say we had to go and figure out what the slope is between 3, negative 2, and 1, I don't know, 7. Okay. So again, I'm going to go and label my points because that's what I do. x1, y1, x2, y2. Great. Now, common kid mistake is you don't label your points correctly. I've seen all sorts of things go wrong with kids labeling points. I've seen kids call this x1 and x2. I've seen kids mix things up when they start plugging numbers in. I've seen all sorts of things, so please be careful with that. And then we're just going to go and plug things into this equation. All right, we're just going to go and do that. And I'm going to use brackets because my point will demonstrate the second common kid mistake. So let's go back to our blue. This is y2, so that's going to be 7. And y1, which is negative 2. Hopefully your spidey senses are tingling right now, thinking about what the possible common kid mistake would be. So hopefully you've identified that you see this double negative here. And double negatives become a positive, so we know that becomes a positive. But a lot of kids think if this is negative, then that just becomes 7 minus 2. No, it's a double negative now. So 7 plus 2, so we get 9. And 1 minus 3 is going to be negative 2. So our slope is 9 over negative 2. All right, let's get on to some other stuff. So we're also going to be looking at how to use the formula if, let's say, you were given a table. It's the same idea, but we'll go through a couple of things here. So it just might look a little bit different. So if I wanted to know, what's the slope from this table. So here's my table. And so here's my x and y's. So sometimes kids kind of take a little while to kind of figure this out. So if I said, like, this is negative 1 and this is 3, and let's say the table kind of went up like this, and there we go. So our ordered pairs, our pairs are like this. So if I was going to go and write this, negative 1, 3, 0, 5, and 1, 7. Now you might be saying, like, okay, well, how do I, there's 3 of them. How do I go and choose my first point and my second point to label them? Well, it doesn't matter because it's going to be a straight line. And for a straight line, the slope stays the same. So you can use any pairs you want. I can make, let's be crazy. Let's go and make this our second point. But we haven't done a first point yet, but that's okay. So I'm going to say this x2. I'm going to say this is y2. I'm going to go all the way over here and say this is x1 and y1. All right. So we're going to go and do our change of y over our change of x. Yeah, I just went fancy. I used a fancy symbol. And I'm still using brackets. And I'm going to go and plug in stuff. So y2, so 3 minus y1, and x2 minus x1. And go 3 minus 7. Okay, I can do 3 minus 7. That's minus 4. And minus 1 minus 2. Minus 1 is minus 2. And that's going to simplify to a slope of positive 2. Boom. There you go. Last question, and then we're done for the standard stuff. Let's give you a question that always pops up on tests. and it confuses the heck out of kids. So if you've paid attention so far, good job. The slope is actually 4/5, and it passes through the following points. It passes through 6 comma -5, and it also passes through x comma 2. What? What are they talking about? So I'm saying I already know the slope, and these are my points. I want to know what this x is. Okay, fear not, young Padawans. I'm going to go and call this x1, y1, x2, y2. And of course, this is m. And remember, our formula is m is, and I'm putting an m over 1. I don't need to do that, but I'm just kind of saying, like, m is 4/5. Okay, so m is equal to, y2 minus y1 over x2 minus x1. Okay, so what does it actually look like? It says then 4/5 is equal to y2 minus y1, so 2 minus 5, and x2, which is x, minus x1, which is 6. Okay, so now we're going to go and cross multiply to solve this. Do that, and like that. And 2 minus 5, boom, it's 7. That's right. I just did that. So watch what I'm going to do. I'm going to go. I'm just going to put a 7 in there just to make my life easier. And let's go and do it. So we're saying 5 times 7, so 35, is equal to 4 times x minus 6. Yes, you have to go and distribute. So don't do the common kid mistake and forget to do that. So you have to go and distribute. You got to go and distribute like that. So what do we end up getting? Well, let's get some more room here. So we'd have 35 is equal to 4x minus 24. All right, I'm going to add 24 to both sides. Add 24. And I would get 59 equals 4x. Divide both sides by 4. And x would be a very, very, very ugly 59 over 4. So this number here would be 59 over 4 if that was the case. And there you go. That might show up on a test from your teacher. You just never know. So that's figuring out slope. All right, so hopefully you have a good understanding of slope and what it means. Now we're going to be taking a look at some word problems and how we can be interpreting some of those as well. Let's get to it. So for challenge, we're taking a look at word problems, and we're going to focus on using slope to solve some word problems. And since it seems to be like a Star Wars sort of theme, we should get some Star Wars characters, shall we? So here's one of my favorite characters, and I'm not a very good artist at all, but let's see if you guys can figure out who would this character be. And I'll tell you a hint. There we go. That was my lightsaber sound effect. And of course, if he has a blue lightsaber, and he's a good guy, and maybe he even has like a hood on him, kind of like episode 4 sort of thing, you should have an idea who that is. Try and guess who it is in class. If you can tell me in class, I'll give you a cookie from the Death Star cookie jar. Pretty exciting. So what's the story? Well, the story is going to be to become a Jedi Master. So if we want to become a Jedi Master, you need to amass 250 Jedi points. You need 250 points. Now, how do you get 250 Jedi points? Well, if you didn't know, perhaps, usually, so typically, we're going to make some generalizations here. Not every Jedi, But typically, Padawans who are in training, those are like Jedi apprentices, after 5 years, they usually have 100 points. And I just want to know, when will our Padawan, I don't know, we'll call him Padawan Douglas, when will he be a Jedi Master? So when will it happen? Okay, well, a couple of things. So now that we actually have some information here, a few things, because we are talking about math, so we should get math involved in this, is here's our graph. So here's our nice graph. And we want to get some equations going. So what would my y and x represent for this kind of stuff? So what is my y going to be equaling? So on the y-axis, what does the y represent? And of course, hopefully you guys get that. It's going to be Jedi points. Jedi points. And then my x, on my x-axis, is going to be time. And we're going to be really specific, of course, and we're going to say my time is going to be in years. Okay, so there we go. That's what we've got going on. And we can draw a line right now. So our very first equation would be y equals 250. So how do you graph y equals 250? Well, you'd go up here on your y-axis and you'd find 250, and you would just draw. That's a horrible straight line. That is a really bad straight line. That is, there we go. Okay, let's get rid of those little things. Let's try and draw a really good straight line. Whoop, that's better. So that represents where we need to get to. So we need our little guys to get to that point. And whoa, what just happened there? Okay, so what was I saying? Y equals 250. So this is the line that we have to get to. So when a Jedi first starts off, so at time zero, how many Jedi points does he have? Absolutely 0. And then what we're going to be doing is we're going to be graphing a line, and these are our years. And we already know after 5 years, he has about 100 Jedi points. So how many years will it take for him to get to that red line? How long does it take? Well, first thing we need to figure out is what our slope would be. So how would we figure out what our slope would be? Well, we're given some really good data points here, and we're given some stuff that we can go and create it. So we have 5 years and we have 100 points. So if we take a look at where that would be, so if this was 1, 2, 3, 4, 5, so maybe, something like there. So 5 years, he has that many points. So we know that this is going to be a linear relationship because we were saying that it's going to be consistent. So we're going to get something that's going to go like this. I missed that spot completely, didn't I? I really did. My apologies. So that's our line, what it's going to kind of look like. There's 0, and there's that one. We're going to say it's linear. And now we can go and figure out what the slope would be. So what's the rise over the run? So what is the rise? So it rises, obviously, 100, and it runs 5. So 100 over 5 would give us our slope, which is going to be 20. There we go. So now we just need to go and make an equation, don't we? And because we know our y-intercept, our b, is going to be 0, that's where it starts, the graph, our equation for Jedi training is simply going to be y equals 20x. Just like that. So what do we really want to know? We want to know, when does it hit this line? So if we had to go and extend these lines, when does it get right there? What does that actually mean? And what that will mean is when he becomes a Jedi from a Padawan. So how do we go and do it? Well, we know that y has to be 250 to get there. So now we can just go and create an equation. And I need a little more room, so I'm just going to go and kind of get rid of this here. So now I just want to say, when do we get to 250 if we're going up at a rate of 20x? So that's really easy algebra to go and solve. I divide by 20 and divide by 20, and 250 divided by 20. What's that going to be giving us? About 12 and a half, something like that. So 12.5 equals x. And that means midway through the 13th year, Padawan Douglas would become a Jedi Master. So, a couple of things. You can go and figure out the slope, and then you just need to go and figure out when basically points will be meeting. And this is how you're using graphs to go and understand word problems. But what would happen if, let's say, you were in a bathtub? So here's your old school bathtub, and the old school bathtubs, there we go. And let's say you're just you're a little bear, and you're in the bathtub. There he goes, and there's his feet. He's just hanging out in the bathtub. And right now there is, I don't know, how many liters would go into an average bathtub? Let's say there's 50 liters. So the bear is in 50 liters of, so he's in 50 liters. Is that a lot or a little? I'm not too sure how many liters go into a bathtub. Anyways, there's 50 liters in there. And we know that when it's time to get out of the bathtub, we know that the water drains at 1.5 liters per minute. And I want to know how many minutes till the water's gone. Till the water's gone. Okay, well, what would a graph look like? So a graph would probably look something like this. Obviously, this is going to be our time, and this would be our water. And we already have one equation, of course, would be y equals 50. So you'd find 50 on the y-axis, and then you just draw a straight line, and that's the water, right? That's all of our water. That represents our water. And now I want to know how many minutes until all the water's gone. Okay, so what's the other equation going to be? So what's our rate? Remember, slope is rate. So that's what I want to know right now. And you're still working in y equals mx plus b. So if we're looking at y equals mx plus b, think of what would the y be and what would your b be. And hopefully what you're saying is, okay, so if I want my y equals, what's my rate? Well, the water's going out, so it's negative, and my rate would be 1.5. X would be my minutes, and I start with 50 liters in there. That's what I want to know. And I just want to know how long. How many minutes would it be? So if I was going to go and graph that line, though, if I want to go and graph it, I would start at my y-intercept, which would be right here. So that's where I would be starting. Let's use a, there we go. So I'd be starting right there. And I'd be going down 1.5 per minute. Now, this might be easier to write actually as negative 3 over 2x plus 50, because when you're doing slope, this means it goes down 3 and it runs 2. Down 3, runs 2. So down 3 and run 2. There we go. Down 3 and run 2. You get the idea. And then you get a nice little line. And you're going to get something like that. Right? Just like that. And remember, I'm going to ask you guys a couple of things. Number one, what does this part represent? Like, what is it in real life? Don't tell me the number. What is it? Well, if you pause the video and just think about it a little bit, it's when the little bear has no more water in the bathtub. All the water is gone. And I want to know, of course, the question was, when is this time? So what is our y value going to be? Our y value is going to be 0. So I want to know, when is there no more water if we have this rate and we already have this? That's what I want to know. So let's go and solve it. So if you're going to go and solve that, so that equation, if you went and solved it, you'd have negative 50, because I go and subtract 50 from both sides, equals negative 1.5x. Divide both sides by negative 1.5. So divide that by negative 1.5, this by negative 1.5, and you're going to get 33 and a third minutes. Now, as I actually hear that answer, it's like, wow, that's a long time for a bathtub to empty. But that's how long it would take to reach where the y value is going to be 0. So right here, this represents 33 and a third, and that's when there's no more water in the bathtub. I mean, you could go and just calculate this right now. That'd be kind of exciting. So real world applications for math. There you go. Hopefully that helped you use graphs and the slope-intercept form and linear equations to solve some word problems. All right, thanks for sticking around. Hopefully you learned a little bit about linear equations and slope. Yeah, grab a cookie, go watch a Star Wars movie. Have a great day. Till next time.